Solve 10 over 1 plus e to the negative x equals 2. Give an exact solution and an approximate solution rounded to 6 decimal places. Again, I'm going to rewrite this below where we have a little bit more room to work with it. And here, before we try and put anything in logarithmic form, it's important to isolate the exponential expression on one side of the equation. This is a little bit challenging because it's currently in the denominator, and so the way that we rectify this is by getting rid of the denominator entirely and multiplying both sides by 1 plus e to the negative x. On the left-hand side, these end up canceling out, and we're left with just 10. And I could distribute the 2 on the other side, but I'm going to leave it just like it is because we're going to want to get rid of it. And so what we can do is just divide both sides by 2 as it is now. If we do that, the 2's on the right-hand side cancel, leaving us with 1 plus e to the negative x. On the left, 10 divided by 2 is 5. And to get that e to the negative x alone, we can subtract 1 from both sides, giving us 4 equals e to the negative x. Now we can write this in logarithmic form. This becomes ln of 4 equals the opposite of x. And then to get the x alone, we divide both sides by negative 1. And we see that x is the negative logarithm of 4. Natural logarithm, that is. This is our exact answer. If we want to get an approximate answer, we can use a scientific calculator. And we end up with x equals approximately negative 1.3862946, etc. And we remember that we need 6 decimal places, so that's going to be the 4, which doesn't get rounded any higher because it's followed by 3. So our approximate value is negative 1.386294. If you're wondering why we want so many digits in our approximation, one example of where it's really important to keep many digits is if we are sending something into space. If we're working for NASA or SpaceX and we're doing calculations and we need to put an approximate value in for some reason, sometimes the difference between 3 and 6 decimal places is the difference between life and death. So we want to get comfortable working with longer approximations because there are situations where that may be important.